All right, we are going to continue working on writing equations. That last example that I did was rushed yesterday, and we're going to work on that just a little bit more today. Before we start, I'd like you to try the first A and B in the example 1. That's review of graphing sine and cosine. Press pause, do it, and I'll show you the rest. All right, so here's the first one. So if you start with the amplitude, it's the absolute value of -2, which is 2. The period is 2 pi over 3. There's your 3. Right, I hope you can see what I'm doing on the screen here. Okay, which if you take 2 pi over 3 divided by 4, you get pi over 6. Draw that, start counting your number line. Then you can get the phase shift by setting the parentheses equal to 0. And that's positive, so I really should have put a plus next to that. And then plus 2 at the end. There's your vertical shift. That's your x and your y. That's your location of your new 0, 0, which you can see is circled in purple in your graph. The domain should be negative infinity to positive infinity. From there, you're going to be going, instead of 0 high, 0 low, there's a negative in front, so it has been reflected over the x-axis. So in this case, the x-axis has been pushed up too. But either way, around that 0, 0 point, it's going to be high on the left and low on the right. So that's been reflected. And the second one, so we've got an amplitude of 1, we've got a period of 2, it's 2 pi divided by b, which in this case is pi. Cut that into fourths, we are counting by 1/2. To get the phase shift, we set the parentheses equal to 0, so we end up with -1/2 for x and a vertical shift of y. We go ahead and put that in and circle it in purple, and there's our new 0, 0. Now, the the point that I've circled here is not the 0, 0, it's the starting point on the graph. If you were to shift, let me show you, -1/2, because we're counting by halves, right? -1/2 and go down 3. There's your 0, 0 in this light blue color, okay? Now, since 0, 0 is not on the graph of cosine, because cosine doesn't go through 0, 0, it goes through 0, 1. From there, you would use the amplitude. You would start with that starting point there that's circled in purple. What else? Domain is negative infinity to infinity. We've got the range, pretty basic. All right, let's move on to writing. No. Do we have an example? Yes. Oh, no, I'm sorry. We've got a graphing example, one more, for tangent. So the amplitude is 2. The period now for tangent is normally pi, but here it's pi divided by b. In this case, the number in front of x is your b, so it's pi divided by 2 is the period. Cut that into nice 4 even pieces. We are counting by pi over 8. So that's the first thing you do. Put that on your graph. Pi over 8. All right, now we are going to, we have options, but maybe I'll find the phase shift next. So go ahead and set the parentheses equal to 0, which my work is right here. So there we go. There's our x coordinate, and the vertical shift is at the end of the equation there, -3. So to get our new 0, 0, we have to go. We have to count left pi over 2. Now we're counting by pi over 8, so we have 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8 is negative pi over 2, right, going left, and then down 1, 2, 3. So there is our new 0, 0. From there, we have an amplitude of 2, so instead of going over 1 up 1, we're going over 1 up 2, and that's where those 2 points come from. If you'd like to figure out the asymptote, feel free to do that by setting what's inside the parentheses equal to pi over 2, because we know the graph does not exist at pi over 2. However, usually after I get this point that's circled in purple, I count to the right and left 2 and draw the asymptotes. That's usually what I do. The domain is everything except for the asymptotes. How do we say that? Pick one. In this case, I usually pick the one to the right of the y-axis, which is pi over 4, because it's pi over 8, plus another pi over 8, 2 pi over 8, which is pi over 4, plus the period times k. In this case, the period is pi over 2. So if I add pi over 2, I'm going to get another asymptote. If I add another pi over 2, I'm going to get another asymptote. All right, moving on. So we're going to take this slowly. We're going to work through this problem and try to write an equation with sine or also cosine graph, because we could actually write both for this equation. So the first thing I usually do is I like to write out the general form of the equation here. So go ahead and write that on your sheet. And it's usually pretty simple to find the amplitude, because you can just find a point, and let's say I'm starting with sine. Okay, I like sine for this graph because if I just move my 0, 0 up 2, I've got the original 0, 0, so that's clearly sine graph, and there's going to be no phase shift, so that's kind of nice. So up 2, down 2, the amplitude is clearly 2. And if I choose to start, back up here, if I choose to just shift up 2, then my d is plus 2 at the end. I have no phase shift. The next thing I need to find is b. So normally the period is 2 pi, right? In this case, if I just pick 2 points and I go to find one full period, so I started at a high point and went down and back up to the high point. If you count from here to here, in this particular graph, it's 4 pi over 6, which is equal to 2 pi over 3. So that's 2 pi over b, which makes b 3. I think we just went through kind of everything. A was 2, B is 3, D is 2, so got all that. So we've got our equation for the sine graph. If we choose to write an equation for a cosine graph, we are going to have to shift our 0, 0, whoops, to the right. And I just picked that point because I liked it. You could have shifted it to left. If you shift it to the left, then you're going to have to also do a reflection, because this starts low and the cosine usually starts high. So to make it easier for me, I just went to the right. I'm going to choose to have a phase shift to the right, which means it should be subtraction because it's an opposite sign, right? So everything else should be the same except for we've got a c. So far we should have 2. The amplitude's the same, cosine, and then your 3x, and then it should be minus c. Now what's c going to be? The way we figure that out is we look at what the phase shift is. In this case, on the graph, it is to the right pi over 6, right? So the whole thing, normally you have that and you set it equal to 0 and you solve for that. Well, we're going to plug in pi over 6 and see what we get. So if we go 3 times pi over 6 minus c equals 0, what is our actual phase shift there? And we've got pi over 2. So just solve the equation. So the formula is bx minus c. So if c is pi over 2, it's 3x minus pi over 2. And then I move this over so you can see the plus 2 at the end. So it's always more difficult when you've got a phase shift. But, you know, sometimes we have them, sometimes we don't. Sometimes you'll be asked to write an equation with phase shift. Sometimes they'll say, do what you like. It just depends on the problem that you're doing. Okay. So let's go ahead and try the U-try. So write one equation for sine and also one for cosine. All right, so the first thing I'm going to, it doesn't really matter where you start, but the first thing I notice is I've got a vertical shift. I've got a vertical shift of minus 2. So there's my d, minus 2. Looks like the amplitude is just 1, because it's like from here to here, this distance is 1, that distance is 1. Okay, but if I just take my 0, 0 and move it down 2, I'm starting with a low value rather than a high value, which means this graph has been flipped over the x-axis. So we have to put a negative in front. And the last thing we'd need in this case, because there's no phase shift, is b. So we got to find the period. So you just pick 2 points, and it looks like I chose 2 high points. I guess I like choosing high points. doesn't really matter. You could choose 2 low points, but you just need to figure out what's one full period. So I'm starting up, going down, all the way back up. So you just count. On this particular graph, the period for this graph is pi over 2. So normally the period for sine and for cosine is 2 pi. So 2 pi over b is equal to pi over 2. How do you do that? Well, you could just think of cross multiplying. So this should be pretty simple. You're just cross multiplying right here. So pi times b equals 2 times 2 pi, and then you're solving for b. So you get b is 4, and then you are, yeah, that's where the 4 comes from. So there's your cosine graph. So if you choose to do sine, again, most of this is the same. Let me erase the graph here. Oh, I'm erasing stuff I copied over. Okay. But then you have a phase shift. So, and again, it doesn't matter which direction you go, but I am choosing to go to the right because if I go left, then I have also reflection I have to do with negative as well, which doesn't really matter, but I just decided, all right, I'm going to go right. So I'm going to be plugging in, it looks like I erased over that. I can't tell. Okay, that is a pi over 8. So you can clearly see the phase shift for a sine graph, because here's your 0, 0, is to the right pi over 8. So I'm going to plug that in to the equation. So 4 times pi over 8 minus c equals 0. So here, there's your c. So it's 4x minus c, and that's what it is. And you can check it, like if you're not sure if it's right or not. I guess that is kind of the most difficult part of this. You can just set your what's inside the parentheses equal to 0 and see if that actually is the phase shift, because that's how you normally do it. But in this case, we're working backwards. You might have to look at this again. So please feel free to pause and look at it again. So now we'll go into equation of a tangent. Okay. So first thing I notice is we do have a phase shift. So it looks like the phase shift is pi over 8. And then we are going up 1, 2, 3. So our d at the end is 3. Our period is normally pi. In this case, from one asymptote to the next, it's pi over 2. So if basically b has to be 2 then. So why do I have b as 3 there? That ain't right. That ain't right. B is 2. Alright, is my D right? My D is up 3. That ain't right. Let's get to a completely different problem. If I was in class, you guys would be like, you guys would have caught that before me. Helping? What the heck? Yeah, alright, so far we've got our B, our number in front of X, and our D plus 3. Okay, so now all we need is, wait, how did I determine A? By looking at these 3 points. Looks like it's over 1, up 1, so the amplitude is just 1. We don't have a switch, like we're going the right direction, so there's no negative. Okay, last thing we need is the phase shift. So we look at the graph, we see the phase shift is pi over 8, so we're going to plug that in for X and solve for C. So you get pi over 4, and then you're done. Just remember that there's a minus in the formula. So if you get positive pi over 4, it's a minus pi over 4. All right, and here is the last one you can do. Press pause, do it on your own, and then see how you do. Okay, so we've got, do you see how this graph starts high? Oops, come on now. Starts high, and then there's your 0, 0, and then it goes low. That has been that's a reflection, which means you're going to have a negative in front. Okay, we've got an amplitude of 2. I guess I should say the absolute value of negative 2, which is 2, and we also have a reflection. So that's why it's a negative 2 in front there. Normally the period for tangent